Thank you for watching Knowledge Academy. Look another.
So in cylindrical coordinate, let's start with cylindrical coordinate. In cylindrical coordinates, if you recall it, we learned about cylindrical coordinate long time ago, and it's supposed to be look like. And really, what do we have is we have this is a y-axis, this is a x-axis, and this is a z-axis. But in the spherical coordinate, we replace these coordinates indifferently. So we don't call y a y anymore. We don't call x x anymore, but we call z still z. So I want to say another way. But with x and y expressed as r and theta. So really x, y, z transform into r, theta and zz. And in this case, when you just have any kind of shape like here, you consider this is r, and how much is travel from x-axis. So I make this direction from x-axis. This is theta. So this is r and theta is basically x and y. And then in going up, you point this guy is z. Okay, and if you want to make like a complete volume, we just take this guy and then round with this, and then you take this guy, we just make a round with this, and then you just connect it, right? And this is cylinder, basically making a cylinder, right? Another way we just talk about that one is we used to write here dv, which is really a differential element out of this. So maybe like this. Right? This is a differential element. I'm going to call this guy is dv. So it's a part of this cylinder. I just break it out of this and call dv. dv used to be supposed to be called in rectangular coordinate is dx, dy, dz. And we also learned that when we convert the spherical coordinate into cylindrical coordinate, we cannot say dr, d theta, dz. These two supposed to be converted into r, dr, d theta, and then dz. Okay. You can write like this, and you have another opportunity. You can write like this: dz, r, dr, d theta. So based on your memory, we can switch back and forth these operators. So this is the best. These are the two most general way you can write in cylindrical coordinate triple integral. You can write r dr, d theta dz, or you can bring the dz in the front if you have any operator which can be easily fixed by dz or integrated by dz. Let's move on. So if you want to write the volume, right, and mass in triple integrals in a cylindrical coordinate, triple integral in a cylindrical coordinate. So I'm writing mass and volume in a triple integral in a cylindrical coordinate. My goal is cylindrical coordinate. We always know how to write a volume in a coordinate system, which is rectangular coordinates. I'm going to be writing here dz, r, dr, d theta. And if you remember, I told you earlier, mass over volume. So if I gave you mass density, what you're going to take? You're going to take this function and multiply by this. So if I'm asking you, give me the mass, you're going to take this function and integrate with respect to v, or multiply by v, or basically you're saying you multiply with dv, and this rho is a density function. Density function. So if this rho is given in a density function, maybe I can call r is not really a density function, could be any function which have three operator, just like x, y, z. Right here is r theta z, and then dz, r, dr, d theta. And I can just write here, I can maybe say here I have nothing, so it means I have 1 when density equals to 1, volume equals to mass. Here f is a density function. Okay, so now take a look on some examples and go from there. I'm trying to solve triple integral in a cylindrical coordinate. So problem, find the volume between the cone, and cone is given like z equals to square root of x squared plus y squared. Okay, I can also write this one is equals to r squared and r. Okay, you can write like r squared and r, and a paraboloid just want to make sure that this is the one we wrote, right? This is the extra stuff that we wrote which is not given in the question. From equals to this is just our explanation, is not given in the question. So make sure that question is giving just z equals to r square x squared plus y squared square root, and a paraboloid z equals to 6 minus x squared minus y squared. Okay, so let's do some simplification and then we talk about how they're gonna look like. So we have a cone and a paraboloid. So cone is given like this shape, right? And then paraboloid is giving for some other shape, maybe here. I'm gonna say this is r. Like this. In order to do that, I'm going to go to the bottom side and then say this is my r, and in the up, if I go there and making a line, like a line like this, maybe red color line. Okay, red color line, I'm going to make it, this red color line is going to cross here, cross here. Okay, and I'm seeing everything from the top. It's going to be look like, if I see from the top, everything is going to be look like this. This is r, right? And r equals to, I'm going to go over there and talk about that. So I'm going to be taking this equation which is giving z equals to 6, z equals to 6 minus right. I can also write like this, 6 minus r square, right? And if I want to So this is my top side. I can also say that 6 minus r square is my, my upper limit, and the lower is 6 minus r square is given as r equals to 2 in the problem on the lower side. So what I'm going to do, I'm going to be just writing a volume 1, 2, 3, and I don't have any function is giving, so maybe like 1 is my density function. We just talked about that in our earlier slide. I'm just going to be writing dz r dr d theta. The last limit is very easy. D theta. D theta means you're going to be making a complete turn from x-axis. It's going to be making a complete turn to 360 degree. So I'm going to be writing like 0 to 2 pi. With r is giving from 0 to 2 in the question. So 0 to 2. Now the leftover is z, leftover here. So I'm going to say z equals to 0. And the upper side here somewhere, I'm going to say this is a parabola equation, and paraboloid is z is 6 minus r squared. Okay, now it's a simple integral, we can solve it. Just need to follow the discipline. If I take the integral for this middle portion, like this guy, is going to be z to limit 6 minus r squared and r, and it's going to be r dr d theta. By the way, is going to be starting from here, this r. So I should be saying this is z equals to r, not z equals to 0, because remember the paraboloid is ending here. So I should be saying this is r. Now let's simplify this. Probably we need to go to second slide to finish this problem. And 6 minus square r dr d theta. Okay, let's go to the next slide. All I can do is just substitute the value of this limit and then go from there. So I'm going to be just writing 0 to 2 pi. I'm going to go back to the slide again one more time so you guys can taking notes. My bad. I'm going to be writing just this. 6 minus r square minus r dr d theta. Now I'm going to be simplified this a little bit if I could, and it's going to be 0 to 2 pi, 0 to 2, and then here 6 minus r square minus r. 6 minus, this is r2, so I'm going to multiply this one to 6r minus r cube minus r square. All I did, I just take this r and multiply everything inside the parentheses. Okay, and I think I'm going to be ready to take the second derivative for this. So 0 to 2 pi I'm going to be writing, and I'm going to take the integral for this one. 3r square minus 1 over 4 r4 minus 1 over 3 r cube, and then d theta. And here I think I just need to apply the limit. So I'm going to apply the limit. It's going to be 0 to 2 pi, then 3 r square times 4 minus 1 over 4, and it's going to be 16, right? 4 to the power 4 is 16, minus 1 over 3 to the power cube is 8, d theta. And then when you minus it, everything becomes minus. So everything will be gone. Okay. If I further simplify this one, it's going to be look like 12 minus 4, and 3 over 8 cannot be simplified further. Now 8 over 3. This is going to be, we can maybe we take the, so further simplify it further before we take the integral. So I'm going to take 3, and it's going to be 3 is 12, 24, 36, 36 minus 4 is 32, 32 minus, I think it's going to be 12, 36 minus 12 minus 8 is going to be 16 over 3. Okay, and then my last integral is 16 over 3 theta 2 pi 0. Let's substitute the value. 16 times 2 and divided by 3, and then pi, and then minus 0 is not going to be count anything, so we don't have to write this one. I'm going to be just wrap up this one is 32 pi over 3, and that is my answer. Let's take a look at another problem which is a little bit different but have a same kind of structure. Find the mass of a solid bounded by z equals to 9 minus x squared minus y squared and xy. With the density function okay equals to 12 minus z. So first thing first, this is my density function is giving. In this question they are asking about mass, not a volume, and we know how to deal it. All we have to do, just rather than we writing 1, we're going to write this 12 by the z and then apply everything like what we used to. So first thing, I'm going to be just writing the function as is. So find the mass of a solid bounded by a paraboloid in xy plane. So probably I'm gonna draw here, and that is my starting point here, and my paraboloid is going to be look like this. And if you can see here, xy plane is in the bottom, which is the bounding. Right. So this is my xy plane, the bottom of this paraboloid. Okay, the equation of this is given is 9 is equals to 9 minus x square y square. I can also write z equals to 9 minus r square, and r equals to plus minus 3. We can only consider plus value because radius cannot be negative. Okay, let's substitute real quick. Mass equals to 1, 2, 3, and I'm going to be substituting the value this function. Here is have a mass equals to 12 minus z, and then dz, see, because we have a z function here, so it's better to I can bring the z up front, and r d theta. So let's fix the z value. Z go from 0 to 9 minus r square. This is given in the question right here. When I substitute z equals to 0, r becomes plus minus 3. It means I'm talking about the bottom boundary. Where is the r? So r, if you want to draw the r from the bottom, it's going to be look like this. And r goes to 3. It's starting from this point. So I'm going to starting with 0 and go up to 3. Theta is pretty simple, 0 to 2 pi. Now it's fairly simple. Integral. Once you're generating these limits, it's easy to solve it. 12z minus z squared divided by 2, and then 9 minus r squared, 0 r dr d theta. I'm going to go to the second page to continue this problem. This one I'm going to be writing again and go back. All I can do is just taking this 9 minus r squared and substituting into the z value, so we can make it simple. So I'm gonna starting with 12 minus 12 minus r square minus half 9 minus r square to the power square and minus 0 dr d theta. All I did, I substitute the value of this 9 minus r everywhere wherever the z is, and we have two places the z is, z time multiplying with 12 and z squared divided by 2. I substitute here, and then minus 0 because the other limit is 0. Let's simplify this further. I'm going to be expanding this. 12 minus 9 is 108 minus 12 r squared minus 9 divided by 2, but I have to open this one. Okay, 9 squared, so I'm going to be using a minus b to the power square, so it's a squared minus 2ab plus b squared. That's what I'm going to be using here. So 981 minus 18, 9 times 2, 18, r is r square because we have a square, and then r square means b square means r square means r4. Close, and then I'm going to be erasing this. This is just for reference. Now I'm going to be writing outside r dr d theta. Let's see if I can simplify this further. So 108 minus 12r squared minus 81 divided by 2, and then 18 divided by 2 is going to be 9r squared plus maybe minus, right? It's going to be minus half r4. Okay, let's see if we can simplify it further. So here I'm going to be just these two terms can be consolidated. These two terms can be consolidated, and then this one is going to stay wherever it is. This is going to be, these two will be 135 divided by 2. 108 times 2 minus 81 is 135 divided by 2 minus, this one should be plus, minus minus plus. I'm going to say minus 3 r square minus 1 over 2 r4. Okay. Maybe I try to solve it here. Let's try if you could fix it. This one is equals to, I'm going to take the integral with this. Okay, so it's going to be 0 to 2 pi 135 divided by 4 r square minus 3 by 4 r4 minus 1 over 12, and then r5. Just do 3. I think this one is r5. I just multiply this one. So 135 r square, and then r, and then 12 r square. Sorry, r5, and then 166, and then 0 to 3 d theta. Okay, let's simplify it before we take the last integral. So 0 to pi, I'm going to multiply the limit. So 135 divided by 4, 3 square is 9, minus 3 over 4, 3 to the power 4 is 9, 27, 81, minus 1 over 2, sorry, 1 over 12, and 3 to the power 6 is 729. We still have d theta. Let's simplify it further before we do it. The last integral, we need to just rid of all these numbers. So it's going to be 1215 over 4 minus 243 over 4, and then minus 243 over 4 d theta. 0 to 2 pi, and 729 divided by 4 d theta. The last integral is pretty straightforward. We're going to be applying 729 over 4, and here is theta with 2 pi or 0. So if you multiply, really is 2 is divided by 2, so it's going to be, this 2 is going to be cancelling when you apply the limit, so it's going to be 729 pi over 2, and that is our answer. Okay, let me see if we have any other problem we can do it. Real quick, the last problem we can do it here about this topic is problem. Solid inside the sphere and the sphere is giving and the upper nap of the cone. Cone is also giving through equation. This is also z squared. So what we're going to do, we just have upper and lower. So let's go to the upper and we go to the outside limit. So here our r on the bottom is 4. If I'm going to be writing here, I can write this equation. Okay, from here z equals to 4 minus, this is also square, 4 minus r square, and I also write z equals to square root 4 minus r square. Okay, and then if I want to be taking from here r is equals to 0, so I'm going to say is 4 minus r square. I can write like this. So that is my first limit. The second limit I'm trying to discover by putting z equals to 0, and here I'm going to take the square root on both sides, so it's going to be 0 equals to 4 minus r square. From r equals to here is plus minus 2. Okay. So what I'm going to do, I'm going to be substituting the value here into my integral. Let's quickly do shortcut since we already know how to do this guy. Here the function is 1, so I don't have to write the density function 1. Then dz dr d theta. Okay, and I'm going to substitute the value is starting from r because this cone is going from this, so z equals to, if I go to here, z equals to r here. Okay, so that's the bottom limit for this dz. My first operator is z, so I'm going to be substituting the dz limit, and upper limit is 4 minus r square. The second limit is r, so it's going to be go from 0 to square root, and then theta is go from 0 to 2 pi. It's fairly simple equation now, and really what we are discovering right now is volume. 0 to 2 pi, 0 to square root 2, and let's do from inside is r, and then I'm going to just substituting the limit for, because it's going to be z minus r square dr d theta. Why the square root of 2? Where is that? Oh, the limit. So is z 4 2 is going to be, yeah, it's going to be only 2. So we just keep it 2 here. Okay, then I'm going to be taking the second integral. Let me just simplify if I could. There's not much we can do here before we take the second integral. So let's take the second integral. So it's going to be minus 1 over 3 4 minus r square and 3 by 2 minus r cube over 3. Let me write one more time if I could on the other slide, or maybe I can write here. I don't need this guy. Here 0 to 2 pi. Let's substitute the limit. Minus 1 over 3, 4 minus 2 to the power square. So it's going to be 4 and 3 by 2 minus 2 to the power 3 is 8 over 3 d theta. And when you substitute 0, everything becomes, if not everything becomes 0. So let's do, we need to do the 0 part. Not everything becomes 0. I'm going to do this part, and then minus plus 1 over 3 4 to the power 3 by 2 d theta. Here let's simplify it before we take the last integral. So this becomes 0, and this one is going to be 8 over 9, and I can say is 2 squared and then 3 over 2 like this. This is going to be cancelling out, so 2 to the power 3 is going to be 8, so I can just do it here. And if I do this, is going to be 64. Let me just do this d theta, and there should be a minus sign. Okay, there should be a minus sign here. So let me just write again 0 to 2 pi with minus and 64 9 d theta. Let's take the last integral. 0, so it's going to be just directly applying. Okay, there's going to be 64 is 120 128 over 9 by minus sign. That is my answer. Look like the volume is going outside the 2 region, or maybe below the floor. That is why it becomes negative. Okay, so today's class we're going to have a continuation for triple coordinates in other coordinate system. Triple coordinates in other coordinate system. Earlier we discussed about triple coordinate in cylindrical coordinate system. Today we're going to be talking about spherical coordinate system. So let's talk about the spherical coordinate, right? Triple integral in spherical coordinate. Here we have, typically we have x, y, z in rectangular coordinate system. If you want to convert this into spherical coordinate system, so really what's happening, if you have x, y, z coordinate, and I'm going to go here, here, come down, leave it here, maybe somewhere here. So I'm going to make the red line, this red line actually, or this red point is my point, what I'm looking for. And what I do, I take this red point and then making a line here, and then this, and connect them. So this is my right point, is my point what I'm looking, and the coordinate is x, y, z. In spherical coordinate, what you do, you just reach out to this right point in a different way. You reach out to a different way, you just go making a line like this, and then you basically, this is like a complete sphere. And you can also making this sphere, you can making also like around, right? You can also making around like this. So bottom line is that in a way, it makes, in a spherical coordinate, you have a sphere, right? A 3D sphere, and this point is on this sphere. So if I'm going to make the line like this, just to give the feeling of we have a spherical line, this point should be on this sphere, and this point is going to be replaced by these three differently. So it's going to be, the first one is going to be rho, then phi, then theta. Okay, rho is nothing but is basically a radius of the sphere. This theta, sorry, phi, the phi is the angle from positive x-axis. So really what does that mean is this point is going to be coming here. You're going to be making an angle. Maybe I can take a white color line, and theta would be this. This is x-axis, so theta would be from green to here. That is my phi. And my theta is the angle from z-axis. So I'm going to be just drawing from here to there. Okay. And I'm going to be just writing here as well. I'm gonna make one correction. I think I did flip-flop those. This is gonna be other way around. Theta is the angle for x-axis, and this is phi. So I'm gonna go back here. That is my theta, and that is my phi. Okay. So these coordinate will be changed into rho, phi, theta. Okay. And now the question is that we have a bunch of formulas. The formulas are simply is, we're going to be writing x squared plus y square equals to r square. Here we're going to make a little bit change because it's 3D, so we need the z, so we can include the z here, and also we can replace the r with rho. That is the first formula. The second formula is that we're going to be using the z equals to r rho theta. So the way I'm just writing side by side, so usually we writing x squared plus y squared equals to r squared. Right? This is my 2D, this is my 3D. So this convert into this. The other one we used to write x equals to r cos theta, y equals to r sin theta. So in 3D, what we're going to do, we're going to replace the r equals to rho sin phi. So wherever we have a r, we're going to replace the rho sin phi. Okay, so it's going to be x equals to rho sin phi and then cos theta, and y equals to rho cos sin phi. It's going to be sin phi again and then sin theta, because it's going to be r is replaced by this sin phi and then sin theta. So really in y we have two both sine, in x we have only one sine and one cos. Okay. Other than that, nothing else is changing. We pretty much have the same one. So we have to remember these three formulas when we do the problem. Another thing we learned, we just say in spherical coordinate, is we used to write delta V R, right? R dr d theta, or we used to write delta V equals to delta X, delta Y, delta Z. Here we're going to be saying delta V equals to delta V equals to rho square sine phi. Rho square sine phi is a common, right? We're going to be just writing this just like we used to write R. We're going to write it like this, and then we're going to be writing the three differential element, which is delta rho, delta phi, delta theta. Okay, this is pretty much whatever. The differential element here is look like this, right? This is a delta X and delta Y, delta Z. Here the differential element is going to be look like this. Okay, this is kind of this, like, it's hard to draw, but this is what it was going to look like. Another two thing is that I'm going to just finish this one. Volume used to be writing differently. We just writing three integral 1 2 3 q, and then r delta r and d theta or dx dy dz. Here we're going to be writing just like pretty much this. So we have this, we can write out this delta v to write like this: rho square sine phi delta rho delta phi delta theta. That's my volume. If it's a mass is given or mass need to be determined, I'm going to be writing same thing: 1 2 3 q here, and here I have a density. We used to write mass density, so I'm going to be writing F is a function of rho, phi, and theta, and then writing again the same thing on the top. Remember, we used to have 1 here. The 1 is replaced by this function. So if the function is given, you're going to be treating the function just like 1. All you have to do is just taking the integral every time you deal with that function, and the operator will be same. Okay, so really these are the formulas we were talking about. We're going to make sure that we're going to keep them in a box, and these are the formulas. Okay, let's talk about a problem to look into this matter into deeper. Find the mass of a spherical shape. Find the mass of a sphere of radius 4, centered at the origin, with the density function F is going to be rho phi theta. It's giving 5 minus 1. Okay. So really what does that is, it's going to be just a sphere. I'm going to draw the sphere. And that's a 3D sphere, so I'm going to be just making like these dotted line. And dotted line this way. Right. And this sphere have a radius of 4. So this radius is going to be go from this center, right, to here is my rho equals to 4. Since I'm seeing everything from the top, it's going to be look like a circular object. So if I see my eyes is on the top, I'm going to see it's going to be look like a circular ball. The circular ball is going to be look like this in 2D. And the radius of this is, I'm going to make a line, it's going to go and then cutting here and add 4. This is 0, right? This is, if this is the x-axis, I can call this is theta or z, right? So what I'm going to be doing, I can see from the top, or I can maybe see from there. I can see from this side, like. So this is my x-axis, this is my y-axis, this is my z-axis. Maybe I can see over here as well. If I see from the top, I can see theta, right? This is my theta. And if I see from the top, from this side, from x, I'm going to see this is my phi. Okay. So the bottom line is that what we can do, we can talk about phi and theta, which one go from where to where. So if you want to make the sphere, you can make d phi go from 0 to pi, right? The phis go from 0 to pi. Phis go from 0 to pi. And just so you know that the phi is angle, so really what is happening, you make a line like this, with a line like this, and then you open the line like a little bit more, you rotate the line, you're rotating here, 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 and this, all these angles is phi. Just go from 0 to pi. Then you're going to take this line, like this line, which is like a orange slice or C shape, and then you're going to be taking this line and you're going to be moving this line and rotate around this axis, and that axis is basically your theta, right? So when you rotate this way, it's going to be 2 pi. Just go from 0 to 2 pi. So let me write this expression, making more sense when you write. We know mass equals to 1, 2, 3, and then I have a function. The function is giving 5 minus rho. Then I'm going to be writing dv. This dv can be replaced by a long expression which we wrote in the previous slides, which is rho square sine phi d rho d phi d theta. That is my function. And that is my dv. Now I'm going to be writing. So the first one is d rho. D rho go from 0 to 4. We already talked about that. D phis go from 0 to pi. We already talked about that. D theta go from 0 to 2 pi. Okay. So I think now is pretty much in control. Let's start talking about
the integral. So the first integral I'm going to be taking the integral for this guy. Okay, let's take a look. 0 to 2 pi is gonna go and stay there like as is. 0 to pi is gonna stay there as is. Take the integral of 5 minus, so 5 is gonna be 5 over 3 rho cube minus rho cube is gonna be rho 4 over 1 over 4. So 1 over 4 rho 4, and the limit is 4 to 0, and then it's gonna be sine phi d phi d theta. Okay, let's substitute the limit and see what's happening. So if I substitute 4 times 4 is 16, and 16 is gonna be 64. 5 times 64, sorry, 5 over 3 64. 5 over 3 times 64 minus 1 over 4 times, you can just maybe say divided by this, so it's going to be 64 times 4, so 128 256 divided by 4 is 64. Okay, so I'm going to just write 64, and then again sine phi d theta. Now I'm going to take multiplication and then simplify further. So it's going to be 0 to 2 pi, 0 to pi, and it's going to be 128 divided by 3 sine phi d theta. Okay, let's take the second integral, which is this one. This is gonna be minus 128 over 3 sine to the integral is cos, right? So cos phi, and the unit, the limit is pi 0 d theta. Let's substitute the limit. Maybe I can erase this one. So I'm going to be writing 0 to 2 pi, and inside minus 128 over 3. Okay, cos phi minus cos pi minus cos 0. So cos pi means cos 180 minus cos 10. So cos 180 is minus 1. We know cos 90 is 0, cos 0 is 1, cos 180 is minus 1. And then minus for the formula, and then cos 0 is 1, so 1 minus 1. And d theta. And again, this is my mass. Let's simplify it a little bit more before we take the last integral, third integral. So it's going to be minus 2, and plus is going to be 256 over 3 d theta. Take our last integral and see how does it go. It's going to be just 256 over 3 theta and 2 pi over 0. We substitute the value. It's going to be 256 over 3, 2 pi minus 0, and if I say multiply this one, it's going to be 512 over 3 pi. That is a mass. Okay. If you want to just do some test on this problem, we can do an exercise. We want to take the sphere, right? And then what we do, we just basically taking this plane, like, I'm going to take this plane, the back side, the back wall, and this wall, and this wall, and this wall, and leave the rest of it plane. So it's going to be only this portion of the sphere left, and this portion of the sphere left, and the other portion of the sphere left. So sphere is going to be look like this. The sphere is going to be look like this. If you really look at the sphere, it's going to be look like pretty much this, and on the back, this is going to be this. It's like you take like a skittle candy and crush into two and then one piece. So really what I did, I just take the half of the sphere, half sphere. Let me say half sphere. And when you take the half sphere, if you don't want to do this problem again, how are we going to write in this expression? And then maybe you can do it for your own practice. 1, 2, 3, rho 5 minus rho, then rho square sine phi, and then d rho d phi d theta. Now here my theta is going to go from 0 to pi, maybe 0 to 4, this one, and then 0 to pi, and this one's going to go from 0 to not 2 pi this time, only pi. Make sure I'm making this guy. Okay, solve it and see what is an answer you got for mass. Solve your own practice and see. Pausing the video, maybe you can solve on your off time and then see what answer you got. Okay, let's look another problem. Find the volume. Make sure you pay attention. This is volume, other one is mass. Inside the cone, theta equals to pi by 3, and inside the sphere, rho equals to 6. Okay, so really what's happened, there's a rho. I'm going to make a sphere. I'm going to take the sphere and this sphere like this, and this sphere is basically giving this is the center point and this is giving 6. Then there is a cone is given, and the cone is going to be look like, this, and this angle is giving pi over 3. That is my angle for the cone, like this angle. And I'm going to take this guy and then plug in here. So it's going to be look like, if I basically what I do, I just add them together, or basically take this cone and plug in inside the sphere, So it's going to be look like this shape. So it's going to be look like this. Yeah, it's going to be look like this. I need to calculate the volume of this guy, this whole solid. I need to calculate the volume for this whole solid. Alrighty, let's jump in and then take a look. The one rule we always using this rule and say, you know what, this is my z, this is my y, this is my x. Okay, and then I'm going to be looking to that. So since when I'm talking about theta and phi, maybe I can see from this side. When I'm going to look at the round, I'm going to be looking from z side. So this, I'm going to look from the x side, and if I look from the x, it's going to be look like a line is going to be passing from this. But if I look from the x, it's going to be look like pretty much this. If I make a line, it's going to go up, it's going to cut on this point, and rho equals to 6. And if I go from here, that's my probably my phi from this one is my phi, and I'm going to be looking to that. So this is my phi from here, so I'm going to start from here to there, right? So is maybe I can say is go from up to from pi by 3, right? And pi by 3, just so you know, when you're making a cone, you can go from cone like this and only take this angle, and this is a pi by 3, not the whole thing, and you just rotate this one. So you take, when you're making a cone, you make this angle and you rotate like this, and this angle is pi over 3, and from here is 0. So really I'm going to just take another color and say here to there 0 here, and then pi over 3 here. That's much easier to understand. So I got two limit. The third limit, if I see from the top, is going to be look like this. And if I see from the top, it's going to be complete. So this axis is going to be complete. 0 to 2 pi. Okay, so let me just write my expression and go from there. So volume equals to 1, 2, 3. I don't have no function. I'm going to just write dv. dv equals to rho square sine phi. Rho square sine phi, then d rho d phi d theta. Okay. Now what I'm going to be doing, I'm going to put in the limit for rho is going to go from 0 to 6. And then phi and theta, we already talk about that. Make sure you understand this limit a little bit better, because these questions are all about this limit. Okay. So everything is under control. Let's do this. Pi over 3, and I'm going to take the integral for this term. Okay, so it's going to be rho cube sine is going to stay there as is, just like a constant. So I'm going to say rho cube over 3 sine. It maybe is much easier if you just leave the sign out, right? If you leave the sign out, because sine phi is a part of the d phi and d theta, and then right here 6 and 0. Now I'm going to substitute the value to solve this. So rho cube 636 and divide by 3. So it's going to be 6 times 6 times 6 divided by 3. So 6 times 6 times 6 divided by 3 is going to be 72. 72, and we're going to say is, yeah, just 72. sine phi d phi d theta. Let's take the second integral, which is now we're going to include the sine, and it's going to be minus 72 cos phi, and the limit is pi over 30 d theta. Okay, let's substitute the limit and see what's going to happen. I'm going to substitute the limit, minus 72 and it's going to be half cos pi by 3 is half, minus cos 0 is 1, and close parenthesis dphi. I'm going to solve here. So this is going to be minus 36, and it's going to be, I think, plus minus minus is going to be minus half, so minus half times minus 72 is going to be 36, and d theta. It's fairly simple now. Take the last integral for this, it's going to be 0 to, sorry, just do the integral this time. It's going to be 36 theta and 2 pi to 0. And what I'm going to do, I'm going to say is 336 2 pi minus 0 is going to be 72 pi, and that is my volume. Okay. Now let's look another problem. In this problem, find the triple integral of a given expression. Okay, so really the integral is given here. Is going to be minus 1 to 5 limit, which is probably z, and let me see, to 0 to pi, just do it. 0 to 2 pi, pi by 4, and pi by 2, and the last one is leaving for the 3 over 0. The function is nothing there, just this. By looking this expression, I know for sure this is a volume, right? For sure this is a volume because there is no mass information is given. So what I'm going to do, I'm going to just do fairly simple, 0 to 2 pi and pi by 4 to pi by 2, and then inside I'm going to say is 9 is giving directly 9 sine phi d phi d theta. And now I'm going to take the second integral, 0 to 2 pi, and it's going to be minus cos minus 9 cos phi pi by 2 and then pi by 4 and d theta. Okay, we can take the substitute the value is going to be like this 9 2 over d theta. Now I'm going to substitute, I'm going to take the last one, last integral, and put in the value. So the integral of this one is going to be 18 pi, right, and 2 over 2. Can I simplify this? Maybe I can simplify that a little bit, not much. So it's going to be volume equals to 9 pi square root 2.
Thank you for watching Knowledge Academy. Please subscribe my channel.